Hey guys, welcome back. In this video I just want to play a little bit around with this functional graphics framework I was working on in a previous video. So the core idea was this type painter, which takes a point on the canvas and perhaps it draws something there. And then we define some, it's a helper function, but then some rendering functions. And we had kind of two backends, one where we render to a ppm and one where we render to ASCII. And just for fun, let's try to run it. So here's with some particular canvas I defined here, where I have two painters, one that paints a circle that is completely white. It doesn't really matter because it's ASCII, it will always be white at this location. And with this radius, another one that paints here, with again white, but at this location and with this radius. And then we define some width and height of the canvas. Now we can also render to ppm. Now it will probably take a little bit longer, so let me try to time it. And while that runs, we can go here and edit. Let's edit a little bit. So what do we want to do today? I think I just want to try to implement the Mandelbrot set. So, okay. Finished in about 18 seconds, so not great. But if we then open this test ppm, it's large and it does not support. So how is it? Is it just convert? Okay, kind of worked. So let's see if okay, I got it open by fiddling around with my terminal settings. But anyway, so here is the picture that it rendered, and we can try to change it a little bit. So this is the canvas, I think. Yes, test canvas, and it just has a bunch of circles. And they're defined here, so we can change something about them. So they're, for example, they're quite big. So here we have some colors, we have a position, and then we have the height here. So we can try to, or the radius. So we can try to make the radius a bit smaller, like so. And render it again. And anyway, so the Mandelbrot set is based on complex numbers, so we want to define something called complex multiply, which basically takes a point, actually takes 2 points and returns a new point, which is kind of like the cornerstone of this. We also want complex magnitude, which should take a point and just return like since we're only working with now it's actually not going to take a point, right? Because we have to convert it into real numbers or something. So let's say float. And similarly here, this has to take 2 floats and return a single float. There's probably a package for this, but I cannot be bothered right now. Okay, so this one did it. Let's see. it didn't really work the way I thought it would, which is great. That's really weird. It's also not easy to read, to be honest. Because these are actually the locations, and this out here is actually the radius. So let's not convert. Let's run it again. Okay, anyway, so how do we multiply two complex numbers? x1, y1, x2, y2. You can look this up on Wikipedia, but it's going to be x1 times x2 minus y1 times y2, and then x1 times y2 plus y1 times x2. This one, we need a square root, and then it's gonna be, here we can just call xy. It's gonna be x times x plus y times y. And now this one, we're like switching back and forth. Okay, so you can see we can like edit what happens. And here we made them quite small. I think it looks nicer. But enough about that. That's just the demo. Let's go back to the coding. So now we have this. Then we want to, let's call it Mandelbrot Painter, I guess. Well, let's make one that's called iterator first. So it should take two floats and it should return an integer. And the way it's gonna work is it's gonna iterate. Actually, it needs a starting point as well. So let's call it C, that's what you normally call it, and set. And then we can say, actually, I'm kind of forgetting how it works. I think it's like this. Let's look it up. So Mandelbrot set. Right, so how is it again? I'm just thinking about what is the starting condition. Yeah, so what is it doing here? It's taking a set squared and adding. Right, okay. So this is actually C, and then we're gonna say go C, and it should go for a maximum of 10. Oh, actually, let's call this helper function iter. So if it is 0, it means that we have no more iterations to. We're not allowed to do any more iterations, and in that case we want the color to be, well, let's actually make this call this max iter, and then we'll say max iter equals 10, and here we'll say reused. Well, why don't we just count up? So we reached number of iterations, we return the number of iterations. Then we can say if the complex magnitude of C is greater than 2, then we return the number of iterations. Otherwise, we should iterate again. The new set is complex multiply set with itself, and we also need complex add, which has the same signature. No, that's fine, right? Yes. Actually, I want to define some helper things. Let's do it like this maybe. And kind of similar here. Maybe this is completely overkill. But now we can say multiply those and then add C. Same C and one more iteration. Now let's try this. And let's try it for this one. Gonna remove that. And what is it complaining about? It needs a float here. No instance of fractional. Ah, right, of course. Now we can probably remove this. Pattern match is redundant. It doesn't look redundant to me. Ah, of course. No, wait. I guess this is the problem. We have to say like so. Okay. So funnily enough, it's because it says greater than. We need to say equal or greater. So now it's 1. And let's take like a point inside, like here, which I think this is 0, if I recall correctly. So this is like -1. And now it uses 10 iterations. I think we can turn this up a little bit, like 100. actually we want to let's make this a maybe, because it's important to know if it doesn't diverge. So basically this condition is saying that if the magnitude is too large, we know it will diverge, just get larger and larger, and that means it's outside the set. So I haven't really explained what the Mandelbrot set is, but maybe I can do that in a different video. But you can look on YouTube, Wikipedia anyway. There's probably also a lot of YouTube videos, now that I think about it. Okay, but the point is that now we can see it doesn't diverge. Let's add here, we can see it diverges pretty soon. And the idea is to use that information to color things. So now let's try to make a Mandelbrot painter. So a painter just takes a point and it returns perhaps a color. And the thing is, it will also depend on the width. So let's say get Mandelbrot painter. It needs a width and a height, and then it will return a function that takes a point and returns a color. A Mandelbrot painter with height, call it point, or whatever. Okay. So it's normal to consider the range like, I'm not sure what this is, but let's say 1.5 to -2 is probably reasonable. And then plus -2. So we want to say, we take the point. What is the point type? It's 2 integers. So let's say like this, x, y, and then we want to, let's define a function that takes x, y and creates coordinates. So this should like return floats. So we need to say I think we have to say from integral x divided by from integral width, and that goes between 0 and 1. So we want to multiply that by the maximum value minus the minimum value plus the minimum value. Just to make it easy, let's do this. Actually, now here it's a bit different. We set 2 to -2. This should be y, and then we can have finally this function which just does chord x, x, chord y, y. Okay, so the idea is that we will say, take the coordinates of this thing, which I might as well call point. So take the coordinates of the point, feed that into the Mandelbrot iterator, and then we want to like map to color. So let's say map to color of nothing. It should be black, and map to color just a number. Let's say like inspired by this. Let's say a small number, because here on the edge, no. So small number is dark blue. And so we can basically say something like, so we have red, green, and blue. Then we can say, it's a little bit annoying that this max iteration is kind of like a global variable now. But whatever, let's put it out there. So let's say times 2. That way, if we're at the max number of iterations, it will be, let's do this, let's try this, see how it works. So anyway, let's see it work. Let's think about where that works. Take the coordinate of the point, we iterate it, we get a color from the number of iterations. I think it's okay. So now let's define a canvas. And just so I remember, call it Mandel canvas. And we want let's say a width of, we can use the same settings that we have up there. A width and a height. And same background color, why not? That shouldn't matter. Let's now try to render it. And let's see how wrong it goes. What? Okay. Right, so this has to be a list of painters, so I have to do this. And couldn't match type. Ah, so these have to be just. Well, it's a little bit weird to have it there. Let's put it here. And again, how do we get a word from an integer is then the question. Maybe I can just write word 8. No. Maybe this one works. That seemed to work. Okay. And it's done. So let's convert it to a PNG. And let's try to, not that one, but try to open it over here. And there you have it. Kind of a Mandelbrot set. You can see the limits that we have are not exactly the same that they have, but get the same structure. Obviously the coloring is not as good here either, but think you'll get the point. So I think that's pretty cool. Should probably we should clean this up a little bit, and then let me add a to-do, which of course should just, you know what, it can be in here. Let's make a to-do, and we'll say add acceleration, because the rendering of each pixel is completely independent from all the other pixels, so we can do it in parallel. We should definitely try that, and then we should clean it up and modularize it. But that's for another video. So hope you enjoyed this one. I think it's kind of fun to work with this purely functional graphics framework, and see you in the next one.